Okay, welcome back, everyone. It's okay. I'll keep it together. Is your name on this? Yeah, that's okay. I'll keep it together. Anybody else have corrections that they want to turn in for the exam? Go ahead and bring those up. Just put them in a pile here. You don't have to do any fancy folding of the corner or anything. Thank you. Anybody else exam corrections? Please turn them in. Is it too much of a glare off of this here? It is. Okay. Okay, so last class, in case you don't recall, what we did was we talked about what it meant to raise something to a power, right? We talked about this thing called a base and an exponent, and how this exponent represented repeated multiplication, right? And we practiced plugging different things in as the base and different exponents, and hopefully learn that the use of parentheses is very important. You know, what's actually being raised to the power, what's not. And at the end of class, we finished up with this quiz that you did in class right here, which I have and I will hand back. In fact, what I will do is I'm going to hand back a stack of papers for you to go through. And just when it gets to you, quickly pull out whatever in here is yours and take it, all right? And then pass the stack around, all right? So I'll start that right here. There might be multiple things in there for you, so go through the whole stack. All right, so that's where we were last class. Now today we're going to pick up the pace a little bit because we were actually supposed to do two sections, I believe 2 sections last time. Yes, and we're supposed to do another section today. We'll see. We'll see how things go. So what we're going to do now is get our first property of exponents that we'll be using the rest of the way. All right, so we have what are called the properties of exponents. And here's the first property we're going to talk about. What if I have something, some base, okay, raised to the n power, and then I come in and I say times the same base raised to a different power. So remember, the base b to the n power means I'm going to do b times b times b times b how many times? This first one right here. N times, right? And then this b to the m power means I'm going to do b times b times b how many times? M times, right? So this looks like b times b times b, and I do that n times, and then next to it, b times b times b, and I do that m times. How many b's total would you have then? If I started counting them, I have 1, 2, 3, 4, 5. How many are here in this first group? How many b's are right here? Well, I have dot, dot, dot. I don't know, but what am I using to say, what am I using to represent how many there should be? N, right? I have n b's here. How many b's do I have here? m of them. So how many total? Let me give you an illustration underneath this. What if I had b to the 4th? Very good. B to the 7th. Wouldn't that be b times b times b times b? So there's my 4 of them, right? And then times b times b times b times b times b times b times b. And I have how many here? 7. So how many b's total? 11, right? You're getting that by doing what? Adding the 4 and the 7 together, correct? So n plus m. So the result, the main property here is that this up here is equal to, and I'll do it in blue, b to the n plus m. And what I think I'll do is down here, I'll write the property real big. I'll just redo it. There's the first property of exponents. Now I want to point out a couple of things about this property, all right? First of all, what's the base in this one right here? What's the base in this first piece? B. What's the base in this one? B. The only way this property works is if it's the same base, right? You have to have the same base here as you have here. If those bases are the same, then this property works. If the bases are different, this property does not work anymore. So let me show you an example of this. I kind of already gave you an example up here, but let me start from scratch with the new example. We'll use that property right there. What would 2 to the 3rd times 2 squared be? According to that property, aren't these the same bases, 2 and 2? They're each being raised to some power, n and m. So this should be 2 to the what power? 3 plus 2, right? Which is just 2 to the 5th power. And then 2 to the 5th you could figure out on your calculator. 2 times 2 times 2, or just by hand or mentally. What would that be? 32? I told everyone to bring their calculators, right? Did y'all bring them? 32. Let's look at another example of this. What if I have w to the 4 times w to the 121? What is that? Well, do they have the same base? Okay, so different exponents on the same base. This equals w to the what? 4 plus 121, which is 125. And that's your answer, right? We can't figure out what that is because we don't know what w is. With me? Okay, what about this underneath this? What's w to the 4th plus w to the 121? There's something subtle here I want you to make sure you understand. What is the operation between these two things here? Addition. Our property does not have addition between it, does it? It doesn't have anything, and when we don't have anything, what is implied? Multiplication, all right? So even though there's not anything there up in this property, that is a multiplication here. Therefore, therefore this is addition, which means this property does not apply, which means this does not add up and become w to the 125 again. So what is this? Well, the property doesn't apply. I just want to make sure you don't confuse it, okay? All right, now let's look at a different property. That's our first property. How about this one? This will be our second one. What happens if instead of having b to the n times b to the m, I have b to the n divided by b to the m? Well, let's look at the example underneath it and see if we can figure it out. What if we have b to the fourth over b to the second? Wouldn't this be b times b times b times b over b times b? Isn't that what that would mean? And then wouldn't we be able to cancel these b's, like cancel 1 and 1, one on the top, one on the bottom, because b over b is a 1. And then cancel another one, b over b, that's a 1. But what's still there? A 2, right? Or 2 b's, I should say. A b squared, right? B squared. So yeah, it's subtraction. What we notice is that that 2 we got actually comes from subtracting these two, right? You take the 4, you take away, if you take that 4 and take away the 2, you would have gotten this 2 over here. So it's not a coincidence, that is the property. So the property says that this will be equal to b to the n minus m. So that's our second property. Questions? I'll leave that up there and I'll give you an example underneath here. What would 5 to the 12th over 5 to the 9th be? Well, we do have the same base, don't we? 5 and 5. The exponent on the top one is 12, the one on the bottom is 9. So subtract, right? So which one, how do I subtract this? Because this does matter. Do I do 12 minus 9 or do I do 9 minus 12? 12 minus 9, which is 5 to the third power, which is 5 times 5 times 5, which is 125. That makes sense? If you look at the two properties we have so far, right next to each other, it says that the one on the right says if you have b to the n and b to the m and you multiply them, all you have to do is add the exponents up. This one says if you have the same thing, b to the n and b to the m, but instead of multiplying them, you divide them, you subtract the exponents. So one of them you add, one of them you subtract. Multiplication, add, division, subtract. Okay? One more example of this. What would z to the 10th over z to the third be? Z to the 7th. Now you don't have to write 10 minus 3. I'm just going to write it so you know where I got this. Z to the 7th. And that's it. You can't figure out what z to the 7th is, right? Because you don't know what z is? Yes. Very good question. Next section. Not yet. You understand the question that's being asked? What if the top was 3 and the bottom was 10? Then it would be 3 minus 10, wouldn't it? And that would give you a negative number. And then what does that mean? So we'll deal with that. We're just not there yet. Okay. Let's get into something a little more complicated. Let's try and combine some things together in the next example. How about x to the 7th, x to the 2nd over x to the 8th? You mean on the top, you mean? Okay, yes. Here's the way we want to work with this. I want everyone to notice that we have a fraction, right? We have a numerator, the yellow, we have a denominator, the blue, right? You can work with those separately first. So look in the numerator, x to the 7th, x squared. Doesn't that look like our first property, right? Like b to the n, b to the n. B to the n times b to the m. Yes? So I could put those two together first. What would that be if I rewrote that numerator? What would it be over here? X to the what? 9th, right? Because you're adding 7 plus 2. Can I just put 9, or do you want me to put the 7 plus 2? Is this okay? Now, what do we still have on the bottom? X to the 8th. Now, look at the whole thing using the second property, right? That's x to something over x to something, same base, subtract. So this becomes x to the 9 minus 8. What's 9 minus 8? 1. That's x to the 1. Anything to the 1 is itself, isn't it? It's just x. All right? Okay, what about this one? How about 3? Let's see if I can get you to negative 3 to the 5 over negative 3 to the 2 times negative 3 to the 2. Now, are my parentheses there just because I love parentheses? No, it's because I'm trying to illustrate, I'm trying to make sure it's clear what is being raised to a power, right? What is the base in the numerator? What is the base? Negative 3. The exponent is 5, right? In the denominator, I have two bases, right? They're both negative 3. So all the bases are the same here, aren't they? They're all the same, which is what we need in order to use the property. So in the problem before, what we did is we tried to do everything up top and then put them together. But I'm actually going to work with the bottom first here, because these two can come together using that property, can't they? Which property, first one or second one? The first one. So if I do the bottom, negative 3 to the 5th, I leave that one alone. On the bottom, what will this become? Negative 3 to the 4th. It's still negative 3, right? You're not multiplying negative 3 times negative 3 here. You're leaving the base exactly the way it was, right? Which is negative 3. And then I'm adding the exponents. 2 plus 2 is 4. Now I have a b to the 5th over b to the 4th, don't I? B to the 5th over b to the 4th. So I subtract the exponents. So this will be negative 3 to the 1. And anything to the 1 is itself, right? So that's just negative 3. Kind of get the idea here? All right, now things start to get more complicated. And only because we're going to start to combine multiple things. You know, up to this point, everything I've given you, it's been the same base to different powers, and we just use these properties. What if I mix things together? Like, what if I'll do something similar to what the book does. I don't want to use exactly what they have. What if I say take negative 5, x to the 3rd, y to the 4th, and then I want you to multiply that times, let's go 4 x to the 7th, y to the 5th. Now that looks bad, but let's just get our head around what's going on here. What are the operations between this negative 5, the x cubed, and the y to the 4th? What's the operation between all those? Multiplication, right? What's the operation in the other parenthesis? Everything between the 4, x 7th, and y to the 5th. Multiplication also, right? What's the operation between the two sets of parentheses? Multiplication. Since everything is multiplication, I don't technically need these parentheses. You only need parentheses when you're trying to distribute over addition or something where you have parentheses and a number outside and you go to each one, right? We've done that. You've seen that. So I don't need the parentheses. So that's the first thing I'm going to do is I'm going to drop the parentheses, -5. And I'm going to put dots between everything just to stress that everything is being multiplied. Okay, now there is a property of multiplication. It's called the commutative, I think it's A in there. Commutative, it doesn't look right. Commutative property. I'm going to have to go back and check that. All the commutative property says is this. Multiplication can be moved around, right? Think about it this way. If I say what's 2 times 3 times 4, you would go 2 times 3 first, right? Which is 6. 6 times 4 is 24. This is 24. But what if I switch it around? What if I do 4 times 2 times 3? So I just scrambled them. 4 times 2 is 8 times 3 is 24. And it doesn't matter how you scramble them, the multiplication is all the same. That's the commutative property of multiplication. So what I'm going to do is I'm going to scramble these around because it won't change the answer. And I'm going to put all my numbers together, all my x's together, and all my y's together so they're side by side. So I'm going to have a -5 times, let me grab that 4 and put it next to it. I have an x to the 3rd. I'm going to grab that x to the 7th, put it next to it. I have a y to the 4th, and then I have a y to the 5th. Good question. Well, there's not a parentheses around it. Are you saying, like, is it the 4 raised to the 7th? Is that what you're saying or no? Yes, they are. They're their own numbers. And that's right. If I had written up here instead 4x to the 7th right there, that would have meant the 4 had to stay with the x. Yes. Okay, now let's just look at these one at a time. What's -5 times 4? -20, right? A negative times a positive is negative. Okay, now the next group, x to the 3rd times x to the 7th. That's the first property, isn't it? Same base, different powers, add them up. 3 plus 7, 10. So this is x to the 10th. The group of y's there, right? There's multiplication between them, same bases. 9. So y to the 9. And that's it. Now, if you get to the point where you can do this mentally, you don't have to show me all these steps. Like if you look at this and say, oh, it's all multiplication. Oh, -5 times 4 is -20. You say x to the 3rd and x to the 7th, I'm going to add. That's x to the 10th. Y to the 4th, y to the 5th, add. I'm going to get y to the 9th. If you do that all in your head, I'm okay with that. Okay? Because that's really where you'll eventually, hopefully, get to that point. But if you're already there, then that's okay. Just be careful would be my only caution to you. Don't get ahead of yourself. All right, next. Let's try 20w to the 7th x to the 5th over 4w squared x to the, no, not 5th, x to the 4th. Questions? You see what's going to happen here? Same sort of thing that we had before. And let me remind you about something with fractions. If I tell you to take a fraction, a over b, and I tell you to multiply times another fraction, c over d, how do we multiply fractions? Straight across. So isn't this the same as I do a times c on top, and on the bottom I do b times d? Yes? Okay. Sorry, that little red is really kind of bothering me. It's been bothering me for a while. So let me get it out of there. All right. Okay, so what I'd like for you to see is this right side. I have things being multiplied on top, right? Then a big division bar, and then things being multiplied on the bottom. I can go backwards from this to this, can't I? I mean, it's an equation, so I can work one way, one side to the other, or so left to right or right to left. What we're going to do here is we're going to see that we have a big division bar on our problem, don't we? Which is kind of like the division bar over here, right? I have a big division bar. What I'm going to do is I'm going to split this up into a bunch of different divisions. The divisions will be, first, all my numbers. So the numbers I have are 20 and a 4, right? So that's 20 over 4. Then times, now let's group my w's together. I have a w to the 7th on top and a w squared on the bottom. Agreed? Then another division, times I have x to the 5th over x to the 4th. Do you all agree with that? If I told you to multiply these all together, right, you would do everything on top multiplied over everything on the bottom multiplied, and that would give us where we started, wouldn't it? Okay, so let's now look at these individually and realize that each one of these we can handle by themselves. What's 20 divided by 4? 5. Okay. What is w to the 7th divided by w squared? W to the 5th, right? Because that's the same base. We subtract the exponents. And what is x to the 5th over x to the 4th? X to the 1st, which is just x. And that is it. Now, you do not have to split it up like I did, okay? If you want to do it all here, you can do it all there. I mean, if you want to just circle, okay, 20 over 4, I do that, then I do this, then I do this. If you want to look at it that way, that is fine. I'm just trying to illustrate why it is we can do it using that property. Questions on that? That's going to finish off 5.1, and here's the homework assignment. I already had given you homework, right, out of this section. I think I stopped at, what, like 61? 61? So I'd like for you to pick up, let's go 65. No, let's do 71, 73, 79, 83, 89, 93. That seems like a lot of problems. I'm not done yet. But those are like the beginning where it's like x to the 5th over x to the 3rd. You know, just to make sure you understand the properties. The stuff that starts to get a little bit weird is from here on. So 95 through 113 odd. So I'll highlight, these are the ones that that would appear more like what you would see on a test, the ones that are highlighted. The beginning set there is just to make sure you got the fundamentals of this down. All right. More properties. You ready for more properties? Of course you are. So we're in 6.2. 5.2. Thank you. 5.2. 5.2. More properties of exponents. All right, before I give you the next property, I'm going to see if we can figure it out ourselves. As a student myself of math early in the beginning, okay, when I was at this point where I was trying to learn this property, it always confused me, and it confuses a lot of students. Let's see, what would you get if you took x and you raised it to the third power, and then you took that whole thing and raised it to the second power? What do you think it would be? You think it's x to the 6th? You think you multiply 3 times 2 and it becomes x to the 6th? Not add? Okay, so as a student, again, it was confusing to me initially because I think I was taught it where here's the property, but it wasn't explained why it worked, right? So I'm going to just show you why this is actually x to the 6th. What does it mean? What does it mean to square something? Doesn't that mean whatever it is times itself? So doesn't this mean x cubed times x cubed again? Isn't that what that means? And doesn't x cubed in parentheses really mean x times x times x? That's the first group. And then multiplication again, x times x times x again. And then how many do I have? 6. So that's x to the 6th, isn't it? Do you see how that is different than the property we just learned? The property we just learned was this property, right? X to the 3rd, x to the 2nd. In this property, you add them, don't you? Because you have x times x times x times x times x. So this one, those 3, this one, those 2. You add those up, you get 5. So I can remember, like as a student, when I was trying to learn this, when I would get mixed up and I would forget them, I would write these 2 examples out, just like this, to help me remember which property you added on and which one you multiplied on, until you get to a point where you just remember it. So here's the property that we're going to have, and I'll do it in blue. Property says if you have x, this is the third property, to the n, and then you take that and you raise it to the m, this is the same as x to the n times m. So you multiply. This is known as the power rule. So let's see this thing in action. As an example, what would 3 squared cubed be? Use the rule. What does the rule tell us this would be? Three to the 6th power. So we're multiplying 3 times 2. And remember our base here, right? Our base is 3, just like the x. Then we have to a power, to a power. So 3 to the 6th. Now we could get our calculator out and figure out what that is. 3 times 3 times 3 times 3 times 3 times 3, right? What is it? 729. Sounds good. In the book, when you're doing the homework on these, a lot of times when you have like 3 to the 6th, that's what they have in the back of the book is the answer. Like they don't actually figure out what 3 times 3 times 3 6 times is. I will want the numerical answer like that. Unless, I don't know, are you using the key that allows you to raise? Who's getting the answer? Are you using that key? There are some problems that your calculator might go crazy. Like, just put this in on your calculator. Try 12 to the 20. What's 12 times 12 times 12 20 times? You got some weird thing? Yeah, okay. 3.83. I'll just say 3.83, and then a bunch of other stuff, and at the end it says E, like this, 21. And yours says raised to the 21st or something like that. Every calculator is kind of different. What this means, this part at the end, means you see that decimal place? You've got to take that decimal and you've got to move it 21 places to the right, which means this is an astronomically large number. Okay? Huge number. Try and do 12 to the 200 instead, and you're probably going to get an error. Overload, overflow, or something like that. That number is too big. The calculator does not have enough memory to be able to know what every digit in that number is. So it's reached its limitation. But that's just a little side note here. To answer the question, I will expect you to be able to get from 3 to the 6th to 729. But I won't give you 12 to the 20th, where it's going to be 3.8 and then the E21. I won't give you problems like that. Okay, how about this one? This one's kind of interesting. What about x to the 2nd times x to the 5th times x to the 6th all to the 3rd? Do what? That's a good question. Do you distribute, are you saying like distribute the 3? Somehow? Yes, we are actually, that's our next property. But what can we do on the inside here? Yeah, those all have the same base, right? And they're all being multiplied together. Times, times. So just add all those exponents up. 2 plus 5 plus 6 is 13. So the inside just is an x to the 13th power. And we still have cubed. Do y'all follow that? Now, use the property that we just learned, the third property, which is the power rule property. Now we can multiply these two together. And that would give us x to the 39th power. Your answer is x to the 39. Any questions? All right, we're going to move to our next property. I'm going to try, before I give you the property, I'm going to do an example. And that way I can help try and motivate how this is going to work. What if I write 3x squared y cubed? What is that cubed acting on? What is that cube, the power, that exponent 3 on the outside of everything, what is it acting on? Everything inside, right? Because the parentheses are there, right? So can I put the 3x squared y together inside? Like the previous problem, we were able to do that, right? What was inside, we put them together and got an x to the 13th. Can I do that here? No, because I've got x's and y's and a 3, and there's nothing to group together. Do y'all see that? Like it is completely grouped together. So the question becomes, how does this 3 affect each of these? So let me try and illustrate it, then I'll give you the property. Do you agree that raising something to the 3rd power means multiplying it times itself 3 times? Right? And what I'm multiplying is 3x squared y, 3x squared y, 3x squared y. So that's what I'm technically doing, right? What is the operation between everything here? Multiplication the whole way across. So do I really need the parentheses? No. And because multiplication is commutative, can I move things around? So couldn't I do 3 times 3 times 3, x squared times x squared times x squared, and then couldn't I do y times y times y? Did y'all see that? Yay or nay? Okay, now we could figure out what these are, right? Like I could sit here right now and I could do 3 times 3 times 3, which would be 27. Don't do it, but that's what I could do, right? And then I could do x squared times x squared, x squared. What would I do here? X to the 6 by adding them up, adding the exponents. And then what about here? Y? That's just y to the third, right? Adding 1, 1, and 1 if you want to look at it that way. But I want you to see something else, because I'm trying to get to a property for you. Do you agree that 3 times 3 times 3 is actually just 3 cubed? Yes? And do you agree that x squared times x squared times x squared is just x squared cubed? Do y'all see that? Isn't that what that meant? And isn't y times y times y, y cubed? So go back up to the original problem here. We had a 3, we had an x squared, and we had a y, didn't we? Sitting inside this parentheses. And then a cubed that was acting on all of them. And the question was, how does that cubed act on these? Well, look at what we got down here. There's our x. There's our 3. There's our x squared. And there's our y. And look at what's on each one of them. A 3. So what's happening here is to get rid of the parentheses, the big parentheses on the outside here, and to get that 3 to act on everything, the 3 has to act on each one of these individually, which is this. Y'all see that? Now, some people call it distribution, distributing the 3 through, but it's technically not distribution. This is distribution. 2 times x plus 4. You distribute the 2 through the parentheses. That is 2 times x, 2 times 4, right? This we are, it's a very loose usage of the word distribute. We are distributing the 3 to each of these, but the 3 is actually a power. We're not multiplying it, we're raising it to that power. Follow me? Okay, so this now becomes, I'm going to go ahead and spit the answer out here, is 27, and then what? What would x squared cubed become? X to the 6th, and then what's y cubed? And that would be it. That's the final answer right there. We will not be doing all this crap in the middle, okay? That's just to show you why the property works. Now here's the property. And this will be what, the fourth property? The fourth property is that, let's say you have something times something, and you want to raise it to the, what do they use, m or n? They use m. M power. Then this should be equal to that a raised to the m, and then that b raised to the m. Now I'm just gonna put like a little line here, like this little curve showing you what happens there. But I'm not going to say distribute. I'm just say, it's applied to each one of those. What is the operation between the two things inside here? What's that operation in between them? Multiplication, right? Go back up to this example. It was 3 times x squared times y. So that when there's multiplication in there, that's what we do. We apply the exponent to everything inside. So let's see if you can handle one now. New one. Oh yeah. You're going to like this. -2 x cubed y z to the fourth to the fourth. I hope that y'all were ready today because there's a lot of information coming at you today, all right? This is one of those classes you don't want to miss. Do we have anything going on the inside of the parentheses that we can deal with? Like, can we put anything on the inside of this parentheses together? No, right? We can't combine. Everything's pretty much condensed down as far as we can go. So now what we want to try and do is get rid of this exponent on the outside. Since there is multiplication, right, on everything inside, I'm allowed to use this property. The property says I take the 4 and I apply that 4 as a power on every single one of these inside. Now, how many things do I have inside? How many of them are there? 1, 2, 3, 4. There's 4 of them, right? So here's what I suggest you do, and this is very critical. Prepare yourself for 4 different things that need to be raised to the 4th power. Right? I'm going to take each one of these 4 things and raise each of them to the 4th power. Now, I put parentheses there because I love parentheses. No, because the parentheses are important. The 4 gets applied to everything that's there. So what goes into this first parentheses here? -2. Do you see why it's so critical I put parentheses around that? If I had not, wouldn't I be doing this instead? Wouldn't you have done that instead? And that is different than that, isn't it? Those are 2 different answers. So do not do that. What goes in the second set of parentheses? X to the 3rd, right? The next one? Y, and then last one? Z to the 4th. Now, each one of these problems is something we can handle. What is -2 to the 4th? Well, that's -2 times -2 times -2 times -2, which you do on your calculator. You should get 16. Positive 16. What's x cubed to the 4th? X to the 7th? 12th? Which one is it? 12th, right? This is the one where you multiply the powers. I'm going to go 3 times 4 and get my x to the 12th. And then what's y to the 4th? It's just y to the 4th, right? There's nothing really to do there. You could, if you want, look at that as being a 1, and then doing 1 times 4 is just 4. What's the last one? Z to the 16th. This is it. We're going to do one more property, and then I'm going to give you some problems to mess with, all right? This will be our last property for today. What are we on? 5? 5th property? Okay, 5th property. What if you have A over B to the M? That's supposed to be an A on top. A over B to the M. Well, this property says pretty much the same thing that the other one said. You can take that M and you can apply it to each one. But when I say apply it, what do I mean? Use it as a power, right? Raise that thing to that power. So this will become the top, which is an A, to the M, over the bottom, which is B, and I'm going to put in parentheses, to the M. So the power goes to both the numerator and the denominator separately. Here's an example of this. What's -3 over x to the 7th to the 3rd? First off, can you do anything inside the parentheses? No, right? I can't do anything. I don't have like x's in the top and bottom that I can put together. So my only choice here is to try to resolve this 3 on the outside. Because I have a fraction, I can take the 3 and apply it to the top and bottom, which means I'm going to create 2 sets of parentheses, a division sign between them, and then what power is on those 3 on those? What goes into the numerator's parentheses? Just -3. What goes into the denominator's parentheses? X to the 7th. Let's do the numerator first. What's -3 cubed? -27, because that's -3 times -3 times -3. So -27 over x to the 21st power, because you're just multiplying 7 times 3. And that's your answer. We're getting close to you practicing here in class. How about four x to the 7th y to the 3rd over 16 x to the 5th y, just y, all to the 3rd. Now we're talking. Now we're talking. Any suggestions? How do you mean start from the top? What do you want me to do with the top? You want to do the 3 on top all the way through? And then the 3, what about the 3 here? I mean, what about the bottom? I can do that next, or, okay? That's one way. That's not wrong. Any other suggestions? That's the way I was listening to you, and I started to get confused. No, okay, I think I know what you're saying. Maybe I'm wrong here. Are you saying try and mess with this before we mess with the 3rd power? What can you do on the inside? You can, right? Couldn't you do, remember how we grouped things together in that example? We did this, and we did this, and we could actually do that also, couldn't we? Now, look, the first approach that was suggested was to take the 3 and apply it on the top and then apply it. That's not wrong. However, it's probably going to lead you to large numbers, and it might be confusing, but it's not wrong. That's the one good thing I can say about math, is that if you follow the rules, you should get to the answer, as long as you don't break a rule. So that way would have worked. It just would have been a little more tedious. So the standard way we do it is we look in the parentheses first, and we say, can we simplify that first? I can figure out what x to the 7th over x to the 5th is, right? What is that? X squared, right? What about y to the 3rd over y? Y squared. So we're using the subtraction property there, right? Where we subtract the exponents. And then what about 4 over 16? One-fourth. Good. So here's what I'll have. This right here becomes 1 over 4. This right here becomes x squared. This right here becomes y squared. Do y'all follow that? X to the 5th, x to the 7th over x to the 5th is x squared. Y to the 3rd over y to the 1st is y squared. 4 over 16 is a fraction that reduces to become 1/4. Now I'm going to put all of that back in here. Are there any questions? Now I'm going to apply that 3 to each one of these. Now how many factors do we have on the inside? How many pieces? We have 3 of them, right? We have 1, 2, there's our third. So that means I'm going to prepare myself here by creating 3 sets of parentheses. Each one of these needs to have what power on them? The 3. Okay, so I'm now applying the 3 to each one of these like that. So what goes in my first parentheses? 1/4. Second parentheses, x squared. Third one, y squared. What's 1/4 cubed? Yeah, it's 1/4 times 1/4 times 1/4. You multiply straight across. 1 times 1 is 1. 4 times 4 times 4 is 64. What's x squared cubed? X to the 6th. What's y squared cubed? Y to the 6th. And we are done. As you can see, things can get pretty complicated. I mean, and we're not to the next section. I'm going to save the next section for next week because we're going to address that question from earlier. Well, what if this number up here is smaller than this number? Then when you subtract them, you'll get a negative number. What does that mean? So we'll deal with that, but let's save it for next week. One thing I do want you to be careful of, all right? Take a look at this problem right here. What if I have x plus y squared? Look in the parentheses right now. Can you put x plus y together? No, right? X plus y is just x plus y. All right, we have a power on the outside, an exponent. Can I apply this to each one and make this x squared plus y squared? No. This is a huge no-no in mathematics, okay? Huge no-no. This is, look at the property. Go back to the property. The property said, I can apply a power into the parentheses if that is multiplication. If it is not multiplication, you cannot do it. Was that a question? Yeah. Y'all see that? So when I go back to what I just showed you, this does not work. Now let me show you, let me just give you a quick example of why it doesn't. 3 plus 2 squared. Right? Doesn't that this kind of look like x plus y and then squared? What's 3 plus 2? 5. So isn't this just 5 squared? And what's 5 squared? Does everyone agree that's 25? Yes? Now try and do it doing this way, which was wrong. What's applying that to both? What's 3 squared? So 3 squared plus 2 squared. Do you see how that's me doing the square on the 3 and then the square on the 2? 3 squared is 9. Plus, what's 2 squared? 4. What's 9 plus 4? 13. 13 is not 25, right? So what's that? Which is the right one? What's order of operations? Parentheses first. You always do what's in parentheses first. So this is a 5, then squared. It is 25. This property does not work. I can show it to you another way if you'd like to see it another way. This is so important that I'm like, any way I can make you remember to not make this mistake, I will try and do, but it's kind of up to you. You want to see one? I can show you a geometric way that it's not true. Sure? Okay. You're just being nice now, I think. Let's see if you can follow it. I might confuse you. Does everybody know if you have a rectangle and you want to know what the area is, that's the part inside. So if I wanted to go paint a wall, I figure out what the area is. You know how to compute the area? Like if the wall, let's say, is 5 feet wide and 8 feet high, what's the area of that wall? It's 8 times 5. It's just the two sides multiplied together, okay? Is that all right with everyone? If I call this, instead of 5 feet and 8 feet, I call this the width, W, and the length, or let's say height, H, then the area would be equal to the width times the height. Okay? That's the area of a rectangle. Now let's see if I can convince you that this gets you sent to math hell. All right? You know, there's certain like sins, I guess, in math. This is one of the big ones, the ones that you do not want to do. All right? Sorry, was that offensive? You don't think there's a math hell? All right. I'm going to draw a picture, and I want to see if you can follow me on this. I'm going to take a little ruler out, okay, and I'm going to measure the distance from that dot in the center there out this way, and I'm just going to say that that distance from here to here is x, okay? And then I'm going to measure another little distance that goes from there to here, and I'm going to call that y. With me? So this is x, and this is y. Got it? Then what I'm going to do is I'm going to reproduce the exact same picture straight up and down. So I measure out, that looks like it's about that x. Do you agree? That's a little long, isn't it? Maybe somewhere around here, okay? That's x. And then y, I'm going to put that on top of it. There's y like that. Go with me? Now, I'm going to create a square out of that. Now, tell me what the total length of this side is, and tell me what total length of this side is. So let's say that x was, in this problem, let's say x was 3 and this was 2. What would be the total length? It would be 5, right? If that was 3 and that was 2, that would be 5. If that was 4 and that was 1, that would be 5. Right? So we're just adding them together. So total length of that side is x plus y. Do you agree? Okay. So that's x plus y. And this side over here would also be what? X plus y. All right. What is the total area of the whole thing then? X plus y times x plus y. So that's where I was saying, like, if you had a door or a wall, you would do this side times that side to find the whole area. Agreed? Okay. So the total area of this whole thing should be x plus y times x plus y, which is the same as x plus y squared, isn't it? Which back here, this big mistake, the big mistake was to say that that was this, right? I'm going to show you why it can't be that. Okay, I'm going to show you why this cannot be this right now. The yellow represents that right there, right? X plus y squared is all that yellow. Okay, take a look at this right here. What is the area of just that right there? Isn't it that x and that x multiplied together? What's x times x? X squared, right? So that right there, just that greenish box, is the x squared. Okay, look, take a look at this box up here. This top right corner up there. What's the area of that box? It's, how wide is it? Here to here, isn't that y? And then from here to here, isn't that y? So this is y times y, so that's y squared, isn't it? So that means this is y squared. So if you think that this on the right side is just x squared plus y squared, you're saying the area of the yellow is just that green box and then that purple or that pink box up in the corner. What are you missing? All the rest of this. What about this and this? Didn't even account for it. So it's not, they're not equal. Now the way to get it properly, let's see if you've ever seen that. The way to do it properly, x plus y squared means this. And then have we learned FOIL before? FOIL, I'm just showing you. If you haven't seen it, don't worry about it. You do x times x first, x squared. Then you do x times y, which gives you xy. Then you do the inner one, gives you another xy. Then you do this one, which gives you y squared. And when you put all that together, you get x squared plus 2xy plus y squared. That's the correct answer. That's what x plus y in parentheses squared is. It's that. Now, it does include those two pieces that you thought it might be, but it also has this very, very important inner piece. And you can see that's the blue. Because look, what's the area of this blue here? How wide is this? Y. How tall is it? It's x. So it's x times y, isn't it? That's xy. And isn't this one x and y? xy? So I have two of them. So 2xy is the piece I'm missing. That's the geometric explanation as to why that rule does not hold. So you cannot use the exponent over addition. Please don't make that mistake. If I give you a quiz, do not make that mistake, all right? Just leave it. If I give you this on a quiz, you just write that again, okay? Just write it right next to it. Don't try and use the property. 7, I talked too much. I'm sorry. Let me give you your homework assignment. Yeah, I'll do attendance too. I was going to do attendance off a quiz. How about a one-question quiz? 7 minutes is enough time. A one-question quiz. And do we want to go easy? We want to go pretty easy? Okay, just one question. Please turn this in on its own sheet of paper. 4x cubed, come on, Robert, be nice, over x squared. There. That took a lot for me to not go any harder than that. There you go. Try and do it on your own right now, okay? See if you can do this. You can look at your notes. Try not to use your neighbor right now. Try and use just what we talked about today. What you wrote down. The homework assignment's going to be put up here with this. You have a lot of homework this weekend. Just turn it in when you're done. You can go. Set it, you know what, set it right there on that corner. Make sure you do turn something in or you'll be counted absent today. It is the 9th. Jeez. Yes. That's a lot of homework.